Hello again. We are going to finish off this unit by talking about a specific kind of series which is known as a power series. So let's get started. A power series is basically an infinite series of the form where basically every term is some constant times x minus b to the k, and k starts at 1 and goes off to infinity. So I've expanded it there for you. Often b is equal to 0, which is really nice. That makes the series look a lot nicer. You don't have those parentheses. But it doesn't always have b equal to 0, so we need to learn how to handle either situation. So as usual, we want to know when such a series converges. Well, a power series can converge either for all x's that are real, for a single value b, which is real, and for all x's such that the absolute value of x minus b is less than r, some capital R, where r is a member of the positive reals. All right, so let's look at an example. Look at the infinite geometric series 1 plus cx plus c squared x squared plus c cubed x cubed, and so on for some constant. I know that this is only going to be convergent when the absolute value of c times x is less than 1. Or basically when x is between negative 1 over c and positive 1 over c. So let's talk about the radius of convergence. In order to find out where a function converges, I'm going to use the ratio test. We talked about that in the last lesson, and we're going to find a radius of convergence. Okay, and that radius of convergence is defined as the largest number r, which is a positive real number, such that the power series converges for x minus b less than r, and it diverges for x minus b greater than r. Okay, if r is equal to infinity, then the series converges for all r's, and if r is equal to 0, then the series converges only when r equals b. But this doesn't tell us whether the series converges for the absolute value of x minus b equals r. We'll need another tool for that. So we'll check those endpoints individually. All right, the interval of convergence, which is different from the radius. Once I check the endpoints x minus b, the absolute value of x minus b is equal to r, then I can state the interval of convergence. And that's the set of all points for which the series converges. It includes all the points where x minus b, the absolute value, is less than r, but it may also include endpoints on that interval as well. All right, so we need an example of this. I need to find the interval of convergence for the power series 4k times x plus 5 to the k, where k starts at 1 and goes off to infinity. So I want to find out which x's this series converges for and which ones it doesn't. So I'm going to use the ratio test first of all to find the radius of convergence. So I look at the k plus 1 term, divide that by the k term, and I take the absolute value of that. So all I did was I rewrote that term that I keep taking the sum of, and I replaced k with k plus 1, and then I replaced k with k, which didn't make a difference. And I made a fraction out of those, and I'm taking the absolute value of that. If I expand 4 times k plus 1, I get 4k plus 4. And I notice that the exponent of x plus 5 is 1 more on the top than it is on the bottom. So basically all I have is x plus 5 to the 1 on top with no x plus 5s on the bottom. And so that's the expression I have. If I divide top and bottom by 4k, then I'm going to get 1 on the bottom for sure, and I'm going to get 1 plus 1 over k on the top where that 4k plus 4 was. All right, so now I'm ready to take the limit as k goes off to infinity. Well, as k goes off to infinity, that 1 over k is going to approach 0, so I'll have 1 plus 0 times x plus 5, and that's just x plus 5. So I need to know when is x plus 5, the absolute value of that, when is that less than 1? Or when is that bigger than negative 1 and less than positive 1? And if I solve that inequality, I get negative 6 less than x less than 4. So I found the radius, and now I need to find the endpoint. So I'm going to check what happens when x is equal to negative 6 and when x is equal to negative 4. So when x is negative 6, I get 4k times negative 1 to the k, and that actually diverges. And when x equals negative 4, that actually diverges as well. So the interval of convergence does not include -6 and it does not include -4, but it includes everything in between. All right, here's another example, another function. So what I'm going to do is I'm going to use the ratio test again. I'm going to put the k+1 term on the top, and I'm going to put the k term on the bottom. And actually what I'm going to do is I'm going to multiply the k+1 term by the reciprocal of the k term. Okay, so you'll see that the k term is upside down and being multiplied after. Now I'm ready to simplify. So there's one more x+3 on the top than there is on the bottom. So that went away. And there's one more 5 on the bottom than there was on the top. So there's just a 5 on the bottom. All right, if I divide top and bottom by k, then the k+1 becomes 1 plus 1 over k, and the k+2 becomes 1 plus 2 over k. As k goes off to infinity, the 1 over k and the 2 over k approach 0, so I'm left with 1 plus zeros in those parentheses. So I just have the x+3 on top and 5 on the bottom. So if I have x+3 all over 5, and that has to be less than 1, then x+3 has to be between -5 and +5, or x has to be between -8 and 2. So I check the endpoints. When x is -8, that sequence converges, or that series converges. It's an alternating series. And when x equals 2, the series diverges. It's actually a harmonic series. So what that means is the interval of convergence will be every x between -8 and 2, including -8, but not including 2. All right, so that is the lesson on power series. That ends the lesson, that ends the unit. If you have any questions, please let me know, and I will see you tomorrow.